Aloha, my name is Gabriel Bansil and I'm a mechanical engineering student. Today I will be presenting my project titled Reducing Non-Renewable Energy Sources with Energy Plus Buildings. So, as the most petroleum dependent state, Hawaii is heavily dependent on non-renewable sources for electricity. Consequently, the use of petroleum and coal for energy contributes to higher electricity prices, risks to energy security, and increased greenhouse gas emissions. As energy demand continues to increase, the environmental and economic consequences highlight the importance of switching to renewable energy sources. So, one solution to reduce non renewable energy usage and greenhouse gas emissions is to integrate the use of solar energy in the form of rooftop solar panels. In this project, I used an open source CAD software to create a 3D model of an Energy Plus building incorporating both rooftop solar panels and building improvements for better energy efficiency. So the place I decided to base my prototype off of was Waikiki because that is the place I'm currently living in. And so we know Waikiki used to be a place filled with greenery and is now very hotel dense and very electricity has a high electricity usage. So for my design, as I mentioned, I use rooftop solar panels because they are one of the fastest growing renewable energy sources. So to prototype this building, I used the CAD software Aladdin to design the Energy Plus building with rooftop solar panels. And so an Energy Plus building is a building that produces more energy than it consumes. And so the energy production from my prototype is solely solar energy. And so the building that I based my design off of was a school building from Alawai Elementary School, which had an average yearly building energy usage of 12,947 kilowatt hours. And this energy usage was based off of the AC energy usage, which takes up the majority of a building's total energy usage. And I also implemented some building upgrades, as I mentioned earlier, through upgrading the insulation. And below, you can see the picture of my prototype with the solar panels and building insulation. And so for testing, to determine the amount of energy used and produced, I utilized the yearly building energy analysis and the yearly solar energy analysis available in Aladdin. And I use that to determine the energy consumption, production, and the energy savings. So for the energy consumption, as I mentioned earlier, is 12,947 kilowatt hours. And the energy production from the rooftop solar panels was 123,717 kilowatt hours. And the energy savings from my building insulation upgrades was 2,917 kilowatt hours. And the graphs below, the first graph on the bottom left shows the amount of energy consumed or the building energy usage for the year. And the bottom part or the green part of the graph shows the amount of energy produced from the solar panels. And the graph on the right shows the amount of solar energy throughout the year produced by the rooftop solar panels. So to conclude, based on the energy consumption and production of my prototype, the number of rooftop solar panels should be decreased to match the energy consumption values. So since currently my prototype is making about 10 times more energy than it is consuming, the number of rooftop solar panels should be decreased to reduce the cost and generate a good amount of electricity. Maybe not exactly 12,947 kilowatt hours, a bit more, so then we can accommodate for both the AC energy usage and whatever else the electricity needs of the building are. And I also found that in testing different areas of my building, Placing these solar panels on the south side of the roof would be more efficient due to Hawaii's position in relative to the sun. So, creating energy plus buildings that are both efficient and sustainable, like my prototype, would allow for a cleaner and more resilient future where fewer non-renewable resources are used. Consequently, fewer greenhouse gases will positively impact the environment, reducing large-scale effects such as ocean acidification and global warming. Thank you.